If you remember, we had in the executing process group, we had managed quality or quality assurance. This is where we're looking at the process. Here in control quality or quality control, this is all about testing and inspecting. Testing and inspecting. So I know here in the Bay Area, we call folks who test and inspect quality assurance people. So I always remind folks that for the next 3 weeks, it's a little bit backwards for you. You got to remember that quality assurance is all about the process. Are we using the right tools? Are we providing the right metrics? All right, are we following the right processes together? And then quality control is deliverable focused. Does it meet its requirements when we tested and inspected, regardless of if somebody took shortcuts or not? We're just looking at the deliverable itself here. All right, so that's what the focus here. And we link this directly with validate scope, if you remember, right? Because validate scope is where we get acceptance, customers validate, we verify in control quality. So we are measuring the completeness, the compliance, and the fitness for use of whatever deliverable we're creating. So we're comparing the results to the quality requirements. Basically, we had our plan quality where we said, okay, this is how we're going to meet the requirements with consistency. We come in with a plan. Now that we produce a deliverable, let's test it and make sure it's meeting its requirements. So the main outputs here are going to be the quality control measurements that we'll use as an input to quality assurance to make sure the plan is working. We'll also get verified deliverables that we'll use as an input to validate scope. That's what the client will take, right? Deliverables that we've tested and inspected. And then the other four are generic, right? Work performance data in, work performance information out. Data becomes information, becomes a report, becomes a project communication, right? So the information out, potentially we could get requests for change to fix a particular product, update our approach, update our documents. We'll get there by taking the plan documents, any approved request, the deliverables themselves, any data we have, ES and OPAs, and then we'll look at these tools and techniques. Let's jump in. We get the measurements as an output, right? The actual performance results. We get work performance information as an output as well in any change request. The verified deliverables, main output as well. Right? It's what we've tested. Do they comply with the specs, the requirements? Okay. We'll take the plan, those deliverables, approve change requests, or performance data. And then how we get there, the tools and techniques, we evaluate, we test, we inspect. So we'll use a check sheet. Whoops. Come back. We'll use a check sheet. I'm gonna have to, let's see. I want to draw a check sheet on here for you. Or, no, let me just show you one. Let me show you one. It might be quicker than going back. A check sheet will look something like this. Open up. Are you all familiar with check sheets? Most folks aren't. Okay. So let me search for it and then pull it up. Check sheet. Let me get your screens out the way so I can see. Okay, goes a check sheet. And then let's change the screen share. New share. Okay, here's a check sheet. Not to be confused with a checklist. Okay. So this is an aggregate check sheet, by the way. Your typical check sheets will have the tallies, you know, like the 1, 2, 3, 4 slash, 1, 2, 3, 4 slash, right? Little check sheet like that. Okay. So this is the aggregate check sheet, and this is in thousands. And I want to say this was like Wells Fargo or something like that, right? So every day they get about 80,000 phone calls a day. And then it dropped down way down here, and then up to a couple 100,000 emails. I mean, phone calls. Emails, they get about 1 million emails a day, jumped up to 3.5, 2.7, started coming back down and normalized by Sunday. They get about, I don't know, roughly maybe 8,000, 9,000 pieces of mail a day. And then it jumped way up, 50, 65. You can initiate a chat session, about 50K, jumped way up, 150, 100, and what that looks like 135 maybe. All right, and then came down to 2. Or you can walk into the branch. All right, and it jumped way up. What are we supposed to happen?
Well, I don't know exactly, but there obviously something related to customer service, some issue.
Payday.
Yeah, it looks like their phone system went down Wednesday night, and so all the people that couldn't call in, they started either initiating chat sessions or they started emailing. And then you had the folks like my uncle who still uses a flip phone. He's like in the 60s. He's walking into the branch. All right, he's this guy walking into the branch. All right, and then in person. All right, and then the emails. They're coming a day later. So notice the snail mail, these are tail-light metrics because it happened here. It took the mail a couple days to get there. And it took some people, they needed to email. Some people came into the branch, but they're closed on the weekends, right? So what a check sheet does is once you get the raw data and you group it like this, now it becomes information. And then this information tells you, I ought to go and inspect my phone system to see what happened, right? So check sheets are what we call tail-light metrics. They've happened in the past. They're not going to tell you about anything in the future, but they will allow you to go back and answer questions about what may have happened so that you can fix things. So used a lot in the transportation industry. Here in the Bay Area, we have something called BART, the Bay Area Rapid Transit. It's like a train system. And this is how they know at what time of day they should have a 5-car train or a 9-car train, right? Just by the, the people coming through the turnstile. So this is how we know the best days to fly are Tuesday, Thursday, Saturday, all right, because we know how many people are going through if you take a look the next time you go to the airport and you really look closely, you're literally going to see somebody there. If you guys watch boxing, when guys are training, there's somebody there and they have a little clicker, and they'll click, 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 click to see how many times in a round did they hit the bag, right? That's like a check sheet. Or you'll see somebody on the trains. You'll see an official worker or somebody at the airport, and they're literally tallying by hand. Checks like slash, 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 right? Line, 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 slash. They're really tallying all the people that they see, right? And so that's a check sheet. And they'll take that raw data, they'll group it into information, and they'll use it to generate a report so that somebody can take some action on it. So that's the check sheet. Now let me come back to, let's come back to the share. Oops, I went way too far. That's the check sheet. All right. Sampling. Sampling is, turn this back on. Sampling is like an all in. It's an all or none. You take a small sample and that represents the entire group. So if one piece fails, the entire thing fails. The best example of sampling that I can give you for a parallel on the exam is going to be, let's say you're making a pot of soup, right? You're making some soup at home and you put a little spoonful in the soup and you taste it. You know what? This soup needs a little bit more salt. That one little spoonful, that sample represented the entire pot. So it either passed or failed. That little spoonful, like passed or failed. So another example, here's a real life example. I worked with a company that was, they do oil rig abatement. So they go and they dismantle these oil rigs. And then Bessie, the Bureau of Sea and Safety, something like that. They're a division of the EPA. They'll come out and they will take a sample of the water on site, 5 meters, 50 meters, 500 meters, and look at the parts per million. And if it's too high, you got to go back and do some remediation work. So that's the idea of sampling. One sample makes the entire population pass or fail. And then we can use questionnaires or surveys. Okay. There is another output called a control chart that comes up on the exam a lot. You write this on here. Something called a control chart. And a control chart will look something like, let me see a space. We have some white space. Here, we'll use this one. control chart will look something like this. You have a line in the middle, and that would be like your goal or your mean or your median. And then you would have some control limits on each side. Right? And this would be your upper control limit, and this would be your lower control limit. And then you may have a spec line. You may have a line that says, okay, as long as you're here, you're within spec. Right? And these would be your specs. And then what will happen, so you have this median, this mean or the goal. And what will happen is, let's say we're making, I don't know, I see a bottle of water here. So bottle of water is 16.9 ounces. So our goal is then to be at 16.9 ounces. And the FDA limits the amount of space you can have at the top of the bottle, right? You can't have too much air and you can't have too little air, right? So then we would have an upper control limit of, say, I don't know, 17 ounces. And a lower control limit of, say, 16.8 ounces. Okay. And so all along the line, and that's our control limit. And it may be spec, maybe the spec number, the government says, okay, as long as it's over 16.6 and as long as it's not over 17.2, you can sell it. So now that we know our spec limits, we're producing our deliverables, but we have a control limit. And so then we're measuring. So now we get our bottles in the conveyor belt and the water dispenses, right? The soda, whatever it is, the next one comes, dispenses, and it's going down the conveyor belt. So then maybe we have like a little laser level or something and it's measuring the water. And so then we're looking and we're saying, okay, we got one here and one there, and this is great. And our control chart should look something like this, right? Hopefully they're right on the line, right? But, you know, every once in a while, we'll get a bottle that'll be here outside the control limit, okay? And so if it's outside of the control limit, it's out of control. It means that we are not going to sell this bottle of water. It is defective. We're going to put it off to the side. All right. So anything that's outside of a control limit, anything that falls outside, even though it's within spec, even though the company, like legally you could sell it, the company says, nope, our quality requirements, it is below the limit or above the limit, it's out of spec. All right. So anytime you get something that's above or below control line, out of spec. The other one is called the rule of 7. And you want to write this down so that you remember this, the rule of 7. And what the rule of 7 says is that if you have 7 consecutive data points on one side of the mean, then your process is out of control. That's the rule of 7. All right, so what I did here on the screen is I put all these data points. We got one here, and we're looking good. We're looking good. We're right on the line. We get here. We're looking good. It's buff. All of a sudden we get 1, 2, 3, 4, 5, 6, 7. I have seven bottles that came in under the goal in a row. I better go and check my production line. Maybe what's happening is the bottle's coming in, it's dispensing, and right before the bottle's leaving, drip. Next bottle comes, it dispenses, right before it leaves, drip. So even though we are within the control limits, our process is out of control. And if we don't go and take a look now and fix it over time, then these numbers are going to keep going down, 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 down. It's going to look like that. All right. So 2 ways to be out of control. The first one, anytime you get a number that's outside the control limits, that's a defect. The second one's called the rule of 7, and that's when you give second consecutive data points above or below the mean, right? Just has to be 7 consecutive on either side. So that's your control chart. Any of you use this? Familiar with this? John, okay, John, you use this, yeah. You know, and this can be used, it's not only quality, this is used even with money and time. We used to move data centers, and we would say, okay, if we had a standard data center that had, 30 or 40 rows with 50 racks in a row, well, then it should take us a certain amount of time to do it. Yeah, and if it would come in above or under, then above or below, then we would have to lessons learned time. Did we grossly over or underestimate? Did we not put the right talent on there? And so you know, you can use a control chart in many ways. This is going to come up on the exam. Bread and butter for PMI. So don't forget the control chart. Out of control if you're above the limits, or the rule of 7. Okay. Let me go back, see if I didn't forget anything else. So we talked about the check sheet, the control chart, sampling.
Hey, DJ.
Yes.
DJ, does the out of control, it's regardless of those 7 points. If you're on the LCL or the UCL, you're still out of control, no matter what
Correct.
side of it you are. Okay, got it. Thanks.
Correct. Yeah, even if it's within spec, like the customer will accept anything as low or as high as this, whatever you set for your control, anything above or below the control is a defect. Now, oftentimes, just to go a little bit deeper, John, oftentimes most companies will set their control limit at the spec limit. You know, if this is what the customer gives me, this is what they ask for. So let me give you an example of how to use this for quality. And I'm going to give you a real example. Here at the Bay Bridge, eastern span of the Bay Bridge here in the Bay Area connecting Oakland and San Francisco, they just redid that like 4 years ago, 3 or 4 years ago now. We have 2019, almost 4 years. And there was a controversy about the bolts, the nuts and the bolts, you know, about whatever compound they used. When it got hot, how much would the bolt expand? And when it gets cold, how much would that bolt contract? Okay. Now, the Department of Transportation has very strict measurements for, you know, how much that bolt can contract or expand or contract given the weather conditions, right? And so here's our spec. I can have a goal here. Here's my item, and as it gets hot, it can expand all the way up here. That might be 2/300ths of a millimeter, and if it gets too cold, they can contract and get this small. Might be another 2/300ths of a millimeter, right? So now I can sell a nut and a bolt for $1 a piece that when it gets hot, it expands all the way here. And when it gets cold, it contracts, right? And then I can say, here's my grade 2 bolt that when it gets hot, it only expands to this limit. And when it gets cold, it only contracts there, right? And then I can make an even higher grade bolt that, you know, it's going to stay within this line here, right? It's not going to expand and contract more than there. And that would be grade 3. So all of them will be high quality, meaning it will meet its requirements with consistency. The nuts and bolts will hold, but then I can have a higher grade as I more tightly control the requirements. Does that make sense? Do you guys see how this control chart's used? So that's the idea there. I would imagine you guys use this maybe in your analysis with water, wastewater, anything? No, not too much. Okay. Oh, I keep going forward. Let me go back. And then we got inspection and testing. That's pretty straightforward as a tool and a technique, and we'll usually put the result on one of these, like a check sheet or a control chart. And then we'll analyze the data. All right, now that we've put the data, we've inspected and tested, put the results in the control chart, now we can analyze that and determine if we're out of control, if our process is out of control, et cetera, et cetera. And then we can go back and do root cause analysis, use a fishbone diagram.